So we're looking cosine law. We're going to specifically look at solving for an angle in it because that usually is the more difficult of bearing. What we're going to do is we're going to memorize just one formula here because usually when they show cosine line, they give you 3 different examples. Do you happen to know any of these off the top of your head?
Um, no,
No?
not off the top of my head.
Okay, so then let's do this. I'm going to give you one. I'm going to call it this one here. And I want you just to try to remember this one. It's c squared is equal to a squared plus b squared. And the reason I tend to use this one is because it's very similar to Pythagorean's theorem to start off. Okay, minus, and then there's this part here you just kind of have to add to it. Minus 2ab cos, and then they're referring to c here, which is angle c. Okay, so I'll do it a little different because that's dealing with an angle. Now the reason I tell you to use this and just memorize this one is you can solve all formulas of cosine with this, and you just have to be strong with your algebra. You just have to be able to rearrange things. So the 2 things you'll either be looking for is you'll either be looking for side C or angle C. That's it. You actually need to know these A and B values. You have to know them in order to use this formula. So in this case, they have actually asked us to use A. A lot of times what they'll tell you to do is rewrite the formula with, okay, A at the end and A here, and then put C in for the A's. It's not the most difficult thing to do, but another way we can do this is really, we can name a triangle anything we want. So let's just say if this is my angle A, and because my formula is set up to find C's, I'm just going to rename that to side C. And then the A and the B, just like in Pythagorean's theorem, so angle C, and this is side C, the A and the B aren't as important, which would make this angle A and this B and this side B. So does this make sense? I've just renamed the triangle. It's completely fine. All I got to do is rename it to whatever side or angle I'm looking for, call them C, and then this formula will work out perfectly for us. Okay? That way I only have to memorize one formula. So we have our one formula here, and we're going to plug in some values. Side C, we do know, is 55. These are all the same unit of measurement, right? I just want to double check that. Yeah, okay, so we didn't have to convert anything. So 55 squared is equal to, side A is 26, so we have 26 squared, plus side B is 32, minus 2 times side A again was 26, times 32. Cos, and C is our unknown, okay? So what we're going to have to do is essentially, in order to solve an unknown, we need to get an unknown by itself on one side of the equation. I can do that a couple different ways. I'm going to assume your algebra is pretty strong. So what I'm going to do here is I'm actually going to move these 2 values here, the lone A and B, like the parts of Pythagorean's theorem. I'm going to move them first to the other side without actually equating anything. So we'll have 55 squared, subtract 26 squared, minus 32 squared is equal to, this negative is still there. It's negative 2, and it's multiplied by 26 times 32 times cos C. Because this is multiplication the whole way through, in order to move this part of the equation, we actually have to divide it on the other side. Does that make sense to you? Yeah. So it needs to become above negative 2 times 26 times 32. Okay. So when we go to rewrite this down below, we're now left with cos C is equal to 55 squared minus 26 squared minus 32 squared. And doing it this way sometimes skips a very common error when simplifying cosine law. A lot of times, and I'll show you an example after, negative 2 times 30. A lot of times what happens with cosine law is people start to simplify and they make an error here where they add and then they actually subtract the value of 2 from the number without doing the multiplication first, which is incorrect because according to BEDMAS you have to multiply first. Okay, so we have that there, and then we just got to move cosine over, and then we'll have our C all by itself. So when we move cos over, do you know what we get?
Inverse.
Exactly. So we need the cos inverse of all of these values. Okay, cos inverse of, and then we just kind of rewrite everything out. And in one step, we can put this into a lot of different calculators can do this in one step. Let me see if yours can there. Is equal to angle C. So our angle C is equal to this in our calculations. So you would put that in. You get a value?
Oops. Yeah. 142.78.
142.78.
Yeah.
Okay. Which would be approximately 143, let's say. Now, I skipped a step here because I do want to show you something. This equation here, let's say I just equated everything, but I didn't put it to the inverse yet. I would have ended up with negative 0.796. And I just wanted to point this out that because we got a negative value in here, if you think of the CAS system, if we're using cos of a negative value, that means we can't be in quadrant 1. And like you said before, in order to have a triangle, the only other quadrant that allows angles small enough to fit into a triangle would be quadrant 2, which means this must be an obtuse angle when we put it in. And that's exactly what we found, okay? So we found our obtuse angle here at 143 degrees. So now our obtuse angle is that value. And that's pretty much all there is to cosine law, especially with just finding an angle.